The function g is defined by g of x equals 6x over 2x plus 3, where x is greater than 0. Part A, find the range of g. So we want to think about the graph for this. So we need to draw the graph. You can use your graphical calculator to help you here. So you can type the function into your graphical calculator. I've already put it into Desmos and I've got a picture of mine here. So if you put this into your calculator, you should get that graph. And remember that x had to be greater than 0. So we are only actually looking at this part of the graph where x is greater than 0. And we want the range of this. So that's the y values. What could the y values be? Well, at the lower end, I can see the smallest that y could be would be 0. And that would be if x could equal 0. Now, we were told that x had to be greater than 0. So therefore, we are not actually including that point. We're not actually including y is 0. But we can say that that's that y has to be anything bigger than 0. So my range, I'm going to say g of x is greater than 0. Can't be equal to 0. Because like I say, we're not including x being 0. So y could be bigger than 0, and then it goes up and up and up, and then we can see it sort of tends towards this asymptote and gets closer and closer and closer to this asymptote, which is the asymptote of y equals 3. So we can see that the function gets closer and closer and closer to 3, but never actually touches it. So therefore, my range is that g of x has to be bigger than 0, but less than 3. That's part A of the question done. Part B. Find g inverse and state its domain. So, first of all, I'm going to rewrite this function as y equals 6x over 2x plus 3. And then we need to remember what the inverse function does. It swaps the x and the y around. That's what an inverse does. So I'm going to swap the x and the y's around. Now I'm going to rearrange this to make y the subject. So I'm going to multiply both sides to get rid of that fraction. I'm going to expand the brackets. I'm going to collect all of the y's together on one side. I'm going to factorise the y outside. And then I'm going to divide both sides by the 6 minus 2x. So this is my g inverse function. I'm going to say g minus 1 of x is equal to 3x over 6 minus 2x. I also need to state its domain. Well, I know that the domain of the inverse function is the same as the range of the original function, because I know that the inverse just flips the x and the y around. So I can just take my answer from A and copy it down, but in the context of it being a domain instead of a range. So we've got x on the inside there. So that's my answer to part B. Next, part C. Find the function g of x, writing your answer as a single fraction in its simplest form. So this is saying to take the g of x function and substitute it in to the g of x function. So I'm going to take the g of x function, the 6x over 2x plus 3, and I'm going to substitute all of this into the g of x function here and here. So g of x will equal 6 lots of the 6x over 2x plus 3, all divided by 2 lots of the 6x over 2x plus 3 plus 3. Now we need to simplify this as much as possible. So first thing, let me just do the 6 times the 6x is 36x over the 2x plus 3. The 2 times the 6x is 12x. Now I don't like the fact I've got these fractions inside a bigger fraction, so to get rid of those, we are going to multiply everything on the top by 2x plus 3 so that these will cancel out. And I'm going to have to multiply everything on the bottom by 2x plus 3. So that's going to leave me with just the 36x on the top because the 2x plus 3 is cancelled out. This 2x plus 3 will be cancelled out. So that's just going to leave me with a 12x at the front. And then we're also going to have the 3 times the 2x plus 3. Now just to simplify that some more, we get 36x over 18x plus 9. We can divide everything there by 9 to get 4x over 2x plus 1. And that's my final answer.